All right, the last lesson for Unit 3, we're going to end it off with talking about some different transformations, which we've already kind of talked about when we graphed in vertex form. But I'm also going to write the equation, so kind of go backwards. So intercept form is the factored form. It's often called factored form. It is the general equation is y equals a, then x minus p, x minus q, where p and q are the x-intercepts. So you'll recognize it as factored form, and then when you solve for x and y, or the two x's, those are your x-intercepts. Vertex form is the one we graphed. It's a x minus h squared plus k, so hk is the vertex. And then standard form is when you multiply it out, it's the ax squared plus bx plus c. So this is the one that you most commonly see. You can solve standard form with like quadratic formula, completing the square, factoring, etc. Factoring is intercept form, and then vertex form is like the a little different. So to write it in intercept form, you need the x-intercept. So these are your p and your q, the solutions, the -6 and the -2. And then you will need your a value. You might be able to figure it out if you look at your vertex and the a value. You go over 1 down 2. So if you think of your x, y, ay chart, and it's typically 1, 1, 2, 4. This one is over 1 down 2, over 2 down 1, 2, 3, 4, 5, 6, 7, 8, down 8. And so if you think about it like that, you can figure out that a has to be -2, because that's the difference between y and ay here, that column. You can also solve for it, but a is -2, p and q are -6 and -2. So it's going to be x plus 6 and x plus 2. So that's my intercept form, factored form. In vertex form, then you need the vertex, which is the hk up here. So it would be y equals a is still -2. The vertex is -4, 8. So putting that back into the equation, it'd be x plus 4 squared and then plus 8, because it's -4 when it comes out, and x minus -4 makes it a +4. So that's vertex form. To get standard form, you have to multiply one of these two out. You could multiply out either one. If you multiply out the vertex form, though, you have to take the x plus 4 squared as x plus 4 times x plus 4. And you'd have to do this first, then multiply that by the -2, and then take that answer and add 8. So it might just be easier to multiply out the intercept form. So -2 and then x plus 6 and x plus 2. So I'm going to multiply this first. So multiplying that out, and you can either just use the distributive property or make a box. So it'd be x times x is x squared, x times 2 is 2x, plus 6 times x is 6x, and 6 times 2 is 12. Combine like terms, that's going to be x squared plus 8x plus 12. And then take the -2 and distribute it to everything inside. So my final answer would be y equals -2x squared minus 16x and then minus 24. And so those are the three forms of the same parabola there: the factored form, intercept form, vertex form, and standard form. So the a value we kind of talked about when we graphed, and this is at Desmo's calculator link if you wanted to check it out. But a, it changes, what does the a do to the quadratic function? It affects the direction that it opens. So if it's positive, it opens up. And if A is negative, it opens down. And then it also, if it's greater than 1, it's a stretch, a vertical stretch. And if it's between 0 and 1, oops, wrong way. So less than 1 but greater than 0, then it's a shrink, a vertical shrink, which means a stretch means it's going to be more narrow, and a shrink means it's going to be wider. How does the change in the vertex affect the parabola? So our vertex of a parabola, we'll call that HK. So the H is the horizontal shift. So it moves the parabola to the right and to the left, and then the K is the vertical shift. And basically it's like the X and the Y coordinate. So if it's positive H, it moves it to the right because the X goes to the right when it's positive, or to the left if it's negative. And then if it's positive K, it moves the parabola up because the Y axis, the positive values go up and the negative values go down. So let's graph one here. So in vertex form, we have the vertex here. You would get positive 5 and then positive 3. So remember, the H always comes out as opposite. The A value is negative 2. My parent function, I'm going to use 0, 1, 2, 3, and then I'm going to square those values. So my parent function is just x squared, so 1, 4, 9. And then multiplying it all by negative 2, the middle column by negative 2. Negative 8, negative 18. Then graphing the first and last column where the 0, 0 is the vertex, 5, 3. And then my axis of symmetry would be this line, then x equals 5, where my vertex is at 5, 3. So 1, negative 2 from the vertex to the right, 1 down 2, reflected over. So 1 away on both sides. Go back to the vertex, to the right 2, down 8, and reflect it over. Down 18 is going to be off my graph, so these 5 points give me enough to draw my parabola. The vertex is a maximum point. The maximum point is at 5, 3 because it opens down. Opens down because A is negative. The domain is all real numbers. X is an element of the real numbers. Their range are all the y values that are less than or equal to 3 compared to the parent function. So A is negative, so it opens in the opposite direction, which would be down. The parent function opens up. It is A is greater than 1, or the absolute value of A is greater than 1 because it's 2, which means it is a vertical stretch. Which means that it is more narrow than the parent function. The vertex is at 5, 3, which means that it was shifted to the right 5 and then up 3. So from 0, 0, I went to the right 5 and then up 3 when I graphed the vertex. So that's the shift. So write an equation for the quadratic function that is narrower, and it's translated to the right 3 units and down 5. So first, my A value in this case is 1. So if I wanted it to be more narrow, it's going to have to be bigger than that. So you could choose an A value that's anything bigger than 1. So 2, 1.5, 3, etc. And then I want to translate it 3 units to the right and 5 units down from where it's at currently. So the vertex where it's right now is going to be 2, 3. So make sure you pull the vertex out. If I'm going to translate it to the right 3, that means I'm going to take the x coordinate and add 3 to it because I'm going to move the x coordinate to the right 3. Down 5 means I'm going to take the y coordinate and subtract 5 to go down 5. So my new vertex in my function would be 5, negative 2. So I took that point, 2, 3, moved it to the right 3 and down 5. It would be at 5, negative 2. It's going to be my new HK. So I'm going to plug that back into my vertex form. And A value can be anything greater than 1, so I'll just do 2. And then x minus 5 squared, and then k is negative 2, so minus 2. This would be a function that works for this description. The a value could be different because anything that's bigger than 1 would be more narrow. Write an equation for the quadratic function that is wider. Whoops, I thought I was on the highlighter. Wider, and then translated left 3 and up 4. So currently my a value again is 1. That's the implied coefficient. So if I want it to be wider, it has to be less than 1. So like a half, a quarter, 50 over 1,000, 5 over 900. It doesn't matter. Something less than 1 anyway. 0.06. So then translated 3 units to the left and up 4 units. So remember to take the vertex out because it's going to be negative 1 means the vertex is at positive 1, positive 2. Then do the translations. If you translate it without taking the vertex out, you're likely to make a mistake with the x coordinate because it's actually opposite when you pull it out. So left 3 means the x coordinate is going to be subtracted by 3. And up 4 means your y coordinate is going to go up 4, so add 4 to the y coordinate. So your new vertex would be at negative 2, 6 if you're doing that math. And then you need the a value to be less than 1. So I'm just going to use a half. And then it'll be x plus 2 squared plus 6 when you plug it back into hk. So it always goes in as opposite for the x coordinate inside the parentheses. So this would be a function that meets those transformations. Quadratic function that's opening in the opposite direction is more narrow and is translated 3 units up and 5 units down. So opposite direction means that this one opens up currently, so I want it to open down, so I want it to have a negative a value instead of positive. More narrow, again, means that the a value has to be greater than what it is right now. It's 1, so I'm going to have to pick an a value that's more narrow. That's going to vertically stretch it, makes it more narrow. And then 3 units left and 5 units and up 5 units. So the current vertex is at positive 4, negative 2. So the x coordinate's always opposite there. 3 units left would be subtract 3 from the x. And up 5 would be add 5 to the y. So it would be at, the new vertex would be at 1, 3. I need a opening the opposite direction. So it opens up, so I want to open down, so negative. More narrow, so how about negative 3? And then hk would be 1, 3. So it'd be x minus 1 squared and then plus 3. All right, we'll do one more. Opens in the opposite direction, wider, and translated left 3 and down 5. So this one currently opens down because a is negative. So to make it opposite, now I need my a to be positive. Wider means that it needs to be less than whatever it is. So it's at 2, so I need an a value that's less than 2. So it could be 1, it could be 1.5, it could be a half, something less than 2. And then my current vertex is at 2, 3. I need to shift it left 3 units, so subtract 3 from the x coordinate, and then down 5, subtract 5 from the y coordinate. That'd be negative 1, negative 2 would be the new vertex. So y equals, it was opening down, I want it to be positive, so opening up. I need something that's wider, so how about a third instead of 2? That'd be significantly wider. And then hk, so x would be plus 1 for x minus h squared, and then minus 2 for plus k. And then that would be my answer. So you could have multiple different answers here because you could choose multiple different a values, but it still meet that criteria. Okay, that's it for Unit 3. So wrapping it up. Test next week, so make sure that you are getting help with this lesson. Don't wait until I see you next because it's too late to ask for help then. We're just going to be reviewing.